Now, I would like to introduce to you somebody who is a rising star in the scene of science. His name is Phil De Luna, and he's one of the top researchers in the growing field of clean energy, featured in the Forbes 30 Under 30 list for energy and a Carbon X Prize finalist. He will talk with us today about his work for the National Research Council of Canada on hydrogen. Hello, Mr. De Luna. Nice meeting you. What
Nice to meet you too.
is about hydrogen that you find so fascinating?
Well, hydrogen is a clean fuel, and it could potentially be the fuel of the future. When you combust hydrogen and use it, the only emission you get from it is water. So you could imagine in a future society being able to replace the majority of our fossil fuel use with hydrogen. And this is particularly important for areas which are hard to decarbonize with electricity alone. Hard to abate sectors like transportation or manufacturing, the sectors that contribute so much to our quality of life. If we can find a way to move past fuels that emit CO2, then we can find a way to potentially go to net zero even faster.
Well, if you look 10 years ahead, what would you think our energy system and our transportation infrastructure will look like?
Right, that's a great question. And I want to begin by saying that hydrogen is just one piece of the puzzle. When we think about the energy transition, there are many different technologies that need to be at play. Battery technologies, renewables like solar and wind and hydroelectricity, nuclear technologies, whether that's small modular reactors or next generation of plants. We really need to think of a whole approach, a holistic approach that makes the most sense in different jurisdictions. In Canada, for example, where we're blessed to have a relatively clean electricity grid, it makes a lot of sense to try to make hydrogen in jurisdictions like Quebec or British Columbia, where we have an abundance of hydroelectricity. Hydrogen is really only clean if it's produced from electricity that in and of itself does not emit CO2. And there are different ways to make hydrogen. And this is kind of the biggest bottleneck right now, which is how do you produce hydrogen and do it in a way that does not emit greenhouse gas emissions? So in 10 years or in the future, I hope to see a really a big push towards a change and transition in our energy systems, where we have renewable energy capacity like solar and wind and hydroelectricity abound. And then we have renewable to hydrogen technologies where we can then capture that renewable electricity and store it into a hydrogen fuel using these new technologies. And then at that point, we can have distributed hydrogen, distributed energy. Why is this important? It means that we can reduce all of the emissions that you would normally see from large scale transportation like air flight or freight or trains or trucks. And this could be potentially extremely exciting for helping us get to our net zero goals.
Well, that sounds like a great vision, but I guess there are some obstacles as well to reach this goal, right?
Yeah, absolutely. Make no mistake, this is going to require a massive amount of investment in infrastructure. And on top of that, there are a massive investment in research and development and science, quite frankly. The International Energy Agency released this year its Energy Technology Perspectives report for 2020. They analyzed over 800 technology pathways, and they found for us to reach net zero by 2050, almost half of the technologies needed to reach this goal are not yet commercial, which means they are either in the lab or at a prototype or even at a pilot demonstration. So there needs to be a massive amount of investment, not only in actually scaling up the infrastructure for transportation of this clean hydrogen, for the production of this clean hydrogen and the utilization, but also on the underlying technologies to help us get there. It's going to take a lot of work. And one of the biggest issues right now is getting the cost down to move, produce, and use hydrogen. At the heart of this is new technologies and catalysts that can convert energy into hydrogen, or membranes or systems. So there's a lot of work still to be done, but it's a very exciting time in the field.
Yeah, I guess so. And we're looking forward to learn more from you in one of the sessions at the World Science Summit. Thank you so much. It was a pleasure talking to you, Mr. Luna.
Thank you so much.